It's just easier.
Hey, John.
Hello, hello.
I do have not a power in this little subject.
Maybe this talk will help me figure out why my students.
I haven't, actually, we just came
Is it
with
still
Bill,
split?
and the office was closed. Our tenant Bill, I hope he's not off the campus, but he's there.
He was doing a test,
Oh.
so the students are probably linger.
That was a nice get together, I thought we had it.
It was.
We don't do that hardly ever.
We don't do that enough, yeah, it was very nice.
Would you all mind signing in? Hi.
Hello, folks.
Hey, Jeff.
Hey. Ay, ay, ay. Barely stand. Is this computer on?
I didn't check it. If Mary Ann is right next door, she can set up anything.
We'll see if we get this set up. I just left class. So, that's where I'm coming from. I know. Am I supposed to be something special?
Yes, you are.
Oh, no.
There we go, excuse me.
Okay.
And then, the USB drive, are just right down there.
Right.
It's,
Okay.
that's right.
And you can log in?
Yes, I'll log in and then it won't take so long to get started up, because I've logged in there before.
Yes, it does take a long time.
Yes, you get thoroughly well.
Oh, is it?
Right, good point, right.
And then,
I just finished kind of like half my chapter, so I figured I'm pretty close.
Good, I'm about one week.
Turn that on.
One of my classes.
I did one.
Yeah.
You just hold it up high.
Good catch.
I'm a little
Or
bit.
in your case, you just hold it up, if you're tall already.
Later, it's already on.
Just record your lecture and then play it like 10%
And then there's this.
faster.
So maybe I gotta, okay.
That's your advancer.
Oh, don't worry, I've got my tricks.
Let's wait another minute, okay, Jeff?
I would hope so, yes, since I'm not ready yet.
And then when we do start, is it all right if we turn these lights out, or we prefer to have them all on?
Let's dim them. Is that enough?
Will that work for you? Can you see whatever you need?
Yeah, I hope that you can see.
All right, so from here you want to choose your top.
Yes. Okay. Use this one. And hopefully this will work. Is this on? Let's see. Mistakes students make. Now,
Now, let me introduce you.
Yes.
All right, why don't we get started then? All right, thank you all for coming, and it is a great honor to have you here today, Jeff. And you all know Jeff Groah from mathematics, and he is going to discuss his current manuscript, Student Errors and What They Teach Us, Mistakes Math Students Make.
you can see that my perspective is from that of a mathematician, since that's my specialization. I think that we can learn about all areas, and I hope to learn from you errors that your students make as well, in light of today's lecture. Yes, I've been writing a book on mistakes that math students make. It currently is some 400 and some odd pages long, but most of that is just archived errors, thousands of errors that students have made. So, let me point out, before I get into the meat of this topic, that is that most of the reasons that students fail occur outside of the classroom. I think that needs to be well understood by both administrators and politicians and whatnot, as they formulate things that they want to do to us, outcomes and testing and all these things. What they need to understand is that when a student is working 55 hours a week, it's not conducive to success. And there are so many things that happen in our students' lives that the modalities by which we teach, and I think we do a fantastic job. We are engaged with our students in ways that administrators can't possibly understand. And that most of the reasons for failure occur outside of the classroom, in my humble opinion. So too many work hours, money, family, transportation, accidents and injury, legal distractions. You've seen it all. Anyone who's taught for any length of time has really seen all of that. Perhaps you know about the play The Rivals, which is an old play. It was one of George Washington's favorites, so it's really old. There is a character, Mrs. Malaprop, and that malaprop comes from malapropos. And so she said all kinds of interesting things. This is just one random line of hers from the beginning of the play. She's talking to a young lady. She says, "You thought, miss? I don't know any business you have to think at all. Thought does not become a young woman. But the point we would request of you is that you will promise to forget this fellow, to illiterate him, I say, quite from your memory." And so this is characteristic of Mrs. Malaprop. She malappropriates words like illiterate. Like illiterate him from your mind instead of obliterate. Okay, so she's always doing that, and that's why she's such a comical character. Solecism. What is a solecism? Those of you who know a little bit about English may know more about solecisms than the rest of us. It's an ungrammatical combination of words in a sentence, and I'd like to give you a mathematical solecism, something I've seen on actual exams. Yes, I understand what the student is thinking. The student is asserting that the limit is this function on the right. But this is an ungrammatical combination of these symbols. Normally the limit must have something that it is operating on. So you don't say that the limit operator equals any particular function. That's just not valid or true. Here's a problem that I gave to introductory algebra students, quite a few of them actually, but I'm going to show you one particular result. It's pretty clear how to perform this subtraction. You subtract the negative, it becomes positive. It becomes a plus, an addition problem. You find common denominators. The student gave me this. This is great. The student is demonstrating knowledge. This is remarkably good. Yes, and the student wrote this next. I would think the answer. Move on. The student thought, you cancel the ones.
Wow.
Yeah. So, what is the student doing? What is going through this student's mind? The student has learned a process.
Misapplication.
The student has learned a process. You cancel stuff in fractions. But what stuff do you cancel? Well, you're supposed to cancel only common factors. Very likely this student doesn't know what factors are, or what terms are for that matter. This student cannot properly formulate the idea of cancellation because the student does not know the meanings of the terms used in the cancellation theorem. The student doesn't know the precise meanings of those words. Here's another common error. We see this all the time. All the way through, calculus 3. There it is. Okay. What's going on? Can you tell me? The student has learned the process, doesn't know when it applies because they don't know the meanings of the words. Right? Okay. I'm going to look now at James Reason's, these professors in Great Britain, error classification scheme based on intention. He has an error scheme based on intention, a mistake. A mistake is an error resulting from a misconception. You have a wrong idea stuck in your head. You're applying that wrong idea faithfully and producing nonsensical or bad results. That's a mistake, which is different from a slip. A slip occurs when you intend to do the right thing, but the wrong thing happens anyway. So the pilot intended to lower the landing gear, but slipped and shut off the engines or something. This would be a slip. And a lapse. A lapse occurs when you know the right thing to do, but it doesn't even come to your mind to do it through carelessness or inattention. So the pilot forgot to lower the landing gear while coming on final approach, and that's why he landed on the belly of the aircraft. Right? He knew he was supposed to lower the landing gear, but didn't through carelessness or inattention. That's called a lapse. There's also a violation. A violation is said to occur if you intentionally do the wrong thing. When I started this project, it never occurred to me that it was even possible for a math student to commit a violation, other than by cheating. Okay? But in an honest solution to a problem, how could they intend to write the wrong thing? I found out later that I was mistaken. I'll show that to you. I added to James Reason's list the blank. That's where you don't even know what the right thing to do is. Okay? So how could you intend it? Okay? You don't know. It's just a complete void in your brain. I think that's a little bit different from these other classifications. This is a mistake. An error resulting from a false idea about how square roots work. Okay? Leading off the theta in this equation is a slip. In all likelihood, a slip. Okay? I saw a PhD in math do this. They know better. They know better, but through carelessness or inattention, did the wrong thing. It didn't occur to them after they started the calculation. Our students do this all the time. They'll take a part of the problem that they're working on, and they'll give that as the complete solution on the next line, because this part is just being carried along. So they will eliminate parts they aren't actively thinking about and only write what they're working on actively at the time. That leads to a lot of errors, and training our students against that bad habit is an important element of getting them to avoid errors. Here's an interesting violation. Okay, I'm asking my students to calculate the derivative using the definition of the derivative here. Use the definition. The student gave me this. Voila! They used the rules of differentiation to calculate the derivative, not the definition, for which I gave them no points, even though the answer was correct. Now, think about what they're doing here. What they're doing is admitting they don't know how to solve the problem in the way that I requested, but they're still trying to prove that they know something. So this violation is actually not malicious. It's an attempt to demonstrate knowledge on the part of the student that I mercilessly gave them no credit for. Okay, so it's still a violation. They intentionally did the wrong thing. And then we have the blank. Yes, a man 6 feet tall is walking toward a lamppost that is 18 feet high. How fast is his shadow moving if he is walking at a rate of 3 feet per second? Here we have Baker Street, and a pipe, and a magnifying glass. And, oh, this is clearly Sherlock Holmes. And he's on Baker Street. He's investigating a mystery, and this problem's clearly a mystery to the student. Okay. So, yes, it's remarkable the things that we get. In this case, demonstrating a lack of knowledge, not knowing what to do on this very simple problem. There are other errors that I had. I want to look at this particular sequence of questions that I asked in a Calculus 1 exam. First question is state the definition of the derivative. The second question is use the definition of the derivative to calculate the derivative of the following function. So back to back, state the definition, use. I've asked this question a large number of times. In every single instance but one, if a student answered the first question incorrectly, they also answered the second question incorrectly. The only instance where the student answered the first question incorrectly and earned perfect credit on the second question is when that person left off the limit but included the limit on the evaluation down here. It may have been a slip. Okay? And so you could say, that you could ask this question: when does a student actually know a concept? Is it sufficient to be able to recite the definition? Or do you need to demonstrate the ability to functionally use that definition? Clearly here, we see that in almost all cases, the ability to functionally use a definition is predicated on your ability to recite it, which is kind of remarkable. This is a remarkable conclusion, and it's rare in subjects outside of mathematics. The ability to formally recite is a prerequisite to the ability to functionally use a concept. And so I ask you, this is a very strange thing. Formal before functional, it's not that way in most non-academic settings. And to prove that, I'm going to ask you a simple question. What is a table? What is an item of furniture called a table? Who here can offer me what they mean when I say, what is a table? Or can you answer this question? What is a table? Do you know? Does anyone here know what a table is? Or are you admitting by your silence that you do not know what a table is?
I tried to tell them once, but I didn't get very far. So someone else should try.
Are we talking about the image?
What is an item of furniture called a table? And this is the table at my house.
Flat surface with legs, or some sort of appendage that holds it up.
Ooh, flat surface with legs, or some sort of appendage that holds it up.
Horizontal, levelly horizontal.
Level horizontal, supported by
Level
legs.
Don't a lot of
Raised by
restaurants
legs.
have legs?
Ah, that's probably.
And don't they also have flat surfaces?
Fish drawers.
Oh, yeah, I can be picky, are you? Aren't there countertops that have legs and flat surfaces?
Yeah.
How flat are we talking about? Can it have any texture at all? Don't some tables have texture? So how flat are we talking about?
The use defines the.
Oh, every tool is defined by its use, and a table is a tool. So what should we say? An item of furniture beside which one may sit and upon which one places objects for ease of manipulation or for display. There you go. Now you know what a table is. But let me point out, even if you didn't have a good working definition for table, you knew what one was. You functionally knew how to use the concept table without formally being able to state or recite a definition. And I think even Webster gets this one wrong, because Webster defines table in terms of observable properties and not in terms of use. So I say this is an error on the part of the dictionary.
That's how we learn language as well. You know how to use verbs and nouns before you can explain what a verb or a noun is.
There you go. I'd say that this is part of most cultures, and perhaps part of human nature, to learn how to functionally use concepts before we formally understand them. And this is something that in mathematics we have to fight against. We have a culture of imprecision and intuition. And this is something that our math students struggle with. It's one of the reasons that students dislike mathematics, is that it's going against a deeply ingrained culture that very few people can identify. That they understand things functionally, but not formally. In mathematics, sometimes that formal ability to recite is a prerequisite for the functional ability to use, which happened in all cases but one on that sequence of 2 questions on a Calculus 1 exam. So, of course, there are other reasons why students don't like math. One might be abstraction, or lack of relevance to their lives, a complex structure of mathematical conventions. There are conventional exceptions to conventions. Which makes things very confusing to students because they interpret one notation one way, where in a particular context it should have been interpreted in a different way. So contextual interpretation of meaning is critical for success in mathematics. It might be that way in your subject too. Higher education, I believe one of the main goals of higher education is to stamp out the intuitive and to weave formal frameworks of knowledge. That's what we do. At least that's what I do, I try to do. Because when my students try to act intuitively, they create errors of false generalization. And this is just so endemic. Psychology is the science of mind and behavior, at least that's what I read in the dictionary.
That'll work.
That'll work? Okay. And note that errors occur in the body, mind, or our behaviors, which means one can study errors from the perspective of psychology. I think it is important to do so. The brain. In psychological literature, you sometimes run across a character named LP. She was a woman, an Italian woman who had encephalitis, which is an inflammation of the brain. And she suffered permanent brain damage to her lateral temporal lobes. Now, how did this affect LP? She continued to have the ability to multiply 3-digit numbers, add, subtract, multiply, divide, carry exponents. She could formally go through those procedures, but she completely lost the ability to understand what any of it meant. I think this is an interesting case because it shows that there's a region in the brain that processes meaning and a separate region of the brain that processes procedures. And there are people who have had the reverse problem. They could understand meaning but couldn't carry out the procedures. You might see this in some of your students. Okay. Not that they're brain damaged. There's another character which I think is insightful, and he just died not very long ago. His name is E.P. in the literature. And over the course of a decade, he met 200 times with researchers. He too had encephalitis. He suffered permanent brain damage, but to the hippocampus. And he lost the ability to form memories. So in those 10 years, every time over those 200 times that he met with the researchers who came to his house to talk to him, every time was a new introduction. Every single time, these people were strangers to him who did not know who they were. However, there's something interesting about E.P. Over the course of time, as the researchers arrived at his doorstep, he knew where to go when they arrived. He learned by habit to go to a table where they would interview him, even though he didn't know who they were, what they were there for. In addition, in his own house, he did not know how to get from where he was to the bathroom. He couldn't tell you. But he could get to the bathroom by force of habit. So we can form these habitual procedures, even if we can't form new memories, which is rather bizarre to think about it. E.P. did not lose the ability to comprehend meaning. He's able to process meaning perfectly well. He just couldn't remember anything. Couldn't form new memories. So memories, procedures, meaning, these are all stored in different locations in the brain. They're handled by different locations in the brain. And you can lose one but not the others, which is rather bizarre, if you think about it. Which one would you rather lose? Yeah. Every time you eat a new dish, it's brand new. You've never had that before. You may have just eaten it 30 minutes ago, but you've never had it before in your recollection. That'd be great. You'd rather lose memory. It's devastating to lose memory, the ability to form new memories. That's absolutely devastating.
That's the worst.
You think that's worse?
I think it's the worst thing to lose.
You'd rather be like LP and lose the ability to process meaning, but retain the ability to perform functions. You can be functional in life, but not process the meaning what you're doing.
They're all bad.
They're all bad. I guess my point is, I don't want my students to have a lack in any of these areas. I want them to be able to form memories, to form procedures and habitualize those things, to form meanings, formal meanings. I want them to have formal meanings, in addition to specific memories that have some level of automaticity and proceduralization to a level of automaticity. I want all of it. And to not teach my students one of these things, to leave out memorization, rote memorization, is to leave a region of their brain underdeveloped. As they go forth from my class, they go forth slightly brain defective because I didn't train them properly. Okay, that's the way I think of it. Okay. Oh, I have to tell you something about my keys. Okay. You know, as I come to the office every morning, and I get out of the car and I walk up to the office, I reach into my pocket as I pony up to the door and I pull out my car key and I try to insert in the lock. And then as I go home in the evening, I leave my office, I walk down to my car, I pull out my keys, and I'm searching for my office key. It seems that my brain has this short-term region. It's not too short-term because it's, of course, the whole day. But it stores the solution to the last lock-unlocking problem. And if I don't consciously think about it, my body will automatically go through the procedure of producing the solution to the last unlocking problem. And so I will exhibit this sort of memory defect. You can imagine our students doing a lot of the same thing. Work on one particular problem, they have a solution to that problem, they might misapply that to another problem, and that doesn't apply.
Well, don't worry, Jeff, those kinds of things only get better as we age.
Yes, yes, I look forward to being a regular EP before I retire.
Look at this all the time in literature. You can't expect me to remember all those authors, can you?
Any number of memory errors when it comes to literature, I'm sure. I wonder about process when it comes to literature. Is there a paradigm that you use? You expect your students to go through some process in analyzing some literary work. And so they need to go through that process. You train them so that that is an automatic process, a level of automaticity, I would imagine. Do they have errors exhibited along this?
Sure. I mean, everyone teaches differently, but there are certain critical paradigms. So there are certain questions you would expect a student to ask himself or herself if you were doing a formalist analysis as opposed to a historical cultural analysis, as opposed to any number of other sociological, psychoanalytic. And so if they ask the wrong question, they're not beginning with the most efficient procedure.
Fascinating. Fascinating. It's a formal procedure being taught. And they can organize their thoughts better with this sort of training. This is great. There's some additional psychology that should be discussed. And one of those that is very important in mathematics is anxiety. There are a fair number of students who have anxiety issues. And for those of us who do not experience anxiety issues, this can be just confounding to us. How could the student have this problem? Why? How can the student be so anxious that they can't function? There are different levels of response that people have in different threatening situations. The student may have been bumped on the head every time they made a mistake by their dad as they solved a math problem incorrectly. They may have a morbid fear of math at this point. Coming to the math class, your math class, you may not know anything about their history and about the fears that they subconsciously experience at this point, but they enter a fight or flight attitude, which kind of shuts down those higher levels of reasoning. This could be a real problem for some students. And those of us who don't have that problem find this just hard to understand, hard to wrap our minds around. But this is real, it's physiological. And so those of us who don't have these anxiety issues need to be informed of the existence of these problems, and so that we can understand and perhaps relate to those who are experiencing them. There are many different words you can attach to problems. One, I'll just mention dyslexia is a mental defect that causes a difficulty in processing symbols. Now, it doesn't affect IQ at all. just affects the ability to process symbols. And this can be a problem in mathematics where there's a blizzard of symbols. Okay? And so that's one thing to think about in terms of mathematics and maybe in your subjects as well. But I would like to say math is the source of some joy to people. We might even say, I might try to say poetically, math is a coy mistress, resistantly revealing her secrets. If you've had the experience of working on a problem, a difficult problem for a long time, and then finally having success, solving that problem, you experience a sort of elation or joy. And this is, I think, an interesting aspect, part of math.
If I may, Jeff, regarding the joy component, as a non-mathematician, you're solving problems in a way that you might not understand how you're solving the problems until you solve the problem. Is that correct? I mean, if you're doing it analytically, then you would just solve the problem. But if you are working the problem, there's epiphanous moments in there that you might not be able to articulate.
Absolutely.
Okay.
That's absolutely true. I wonder if that happens in psychology.
Okay, serendipity, and yeah, epiphany happens all over the place.
I think a lot of psychologists have had epiphanies about human behavior. And they probably felt a great deal of joy in perhaps finding a context or meaning for the behavior that they were looking at that seemed so inexplicable before. So I can imagine that there have probably been many such moments, some of which are probably completely bogus. Like, if you've ever read Karl Popper. Karl Popper talks about Freud and Adler and how he didn't believe their theories were scientific. And Popper was right. Okay. That their theories were not scientific. They had great explanatory power, these theories. Enormous explanatory. In fact, they could explain virtually any behavior that you observe. And Adler and Freud had great success saying or interpreting behavior within the context of their theory. The problem there being that if a theory has such great explanatory power that it explains everything, then there's no falsifying it. Which means that it can't possibly be scientific. It's just like Popper applied this to Marxism. And the Marxist theory of history says that it's not falsifiable, you can always reinterpret it. And everything that you read in the newspaper can be interpreted in terms of Marxist theory of history. And so, since it has this enormous explanatory power, it's absolutely worthless as a scientific theory because you can't falsify it. Okay, so what do students really want? They want to know how to do the homework. They want to know the process to get the homework done, but they don't want to learn specific formal meanings because that's against their culture. As we've explained earlier, it's against our culture to learn specific formal meanings, and they're very resistant to it. They do not want to memorize specific facts, despite the fact that memorization of specific facts may be a prerequisite for extending conceptual knowledge. It could be a real problem. How do you extend the conceptual knowledge if the student has resisted memorizing the necessary facts to wrap their mind around this new concept? And they do not want to automatize procedures. They just want to be able to execute the procedure to get the homework done and move on. Okay. They don't want to reinforce it to the point where it has some level of automaticity. So they do not want to develop specific regions of the brain. That's what I want you to think about. These are different regions of the brain we're talking about. And they want their brain to remain atrophied. Of course, it's a matter of entropy. Well, a matter of inertia, rather. Okay. So they're resistant to all of this. I'd like to say that there are perceptual errors, memory errors, procedural errors, meaning errors, logical errors, inductive errors, and communication errors. You could write a book on each of these. I think that's true. A perceptual error, there are many TV shows dedicated to perceptual errors. Okay. And communication errors, we hire a whole lot of English professors and literature professors to speech professors to train people with respect to communication, and they still struggle for years. You know, all the way through college, from K through birth through college. A little bit about perceptual errors. There are transcription errors that are very common. First thing, when a student gets to my office with a homework problem, I want them to open the book and let me see if they've transcribed the problem correctly. There's no point in me going through the mistranscribed problem just to discover that their problem has no solution or has a really messy solution, whereas the original problem of the text was pretty tame and mild. People often substitute the expected or desired for the perceived. This happened to me when I applied for my first driver's license. I went and applied for a driver's license, came in the mail. Jeffrey Marvin Groan, G-R-O-A-N, not G-R-O-A-H. Okay, well maybe that was more apropos. But yeah, that was whatever they wanted to see, they saw. No matter how high I put that little H, the stem on the H, it's still going to come out grown or grow, G-R-O-U-G-H or G-R-O-W or any number of different incorrect spellings. People see what they want to see. Okay, our students see what they want to see. They see what they expect to see. We may write something perfectly sensible on the board, and they may copy something perfectly nonsensical. Okay. And this happens all the time. There's something called inattentional blindness, which is also an interesting psychological effect. When the mind is actively working on a problem, it can displace perceptions. You may be concentrating on, there's a famous video, the invisible gorilla, you may know about. And for half the people who watch that video, they do not see the gorilla, even though the gorilla walks into the middle of the group, pounds its chest, and raises its arms and moves and walks off. This goes right through the middle of the scene. Half the people who watch the video don't even see it. Okay. It's called inattentional blindness. You've given them a task to think about, they're concentrating on that task. They're counting the number of times the players with white shirts are passing the basketball amongst each other. They don't even see the gorilla walking in the middle. Okay. And this can happen with us too. My students' minds can be so preoccupied with different tasks that we've assigned to them during the course of the lecture that they don't even see the next thing we write. Okay. And so inattentional blindness is real, it's out there. The higher the cognitive load, the less of the perception that filters through to consciousness. Though it is possible for someone to respond to a perception without consciously being aware of it. There's a cognitive psychologist I read, wrote a book called Consciousness. His name is Christoph Koch. He describes how he was running in the hills outside Pasadena, and he found himself leaping to the side of the path, only to look down and realize he had just left aside a rattlesnake in the path. So the body filters what goes into consciousness. Sometimes the perceptions are so important that the subconscious mind has to cause a physical reaction prior to that rising to the level of consciousness. Okay, so that does happen too. There's something called the Perky effect. If you've ever heard of that? Perky effect is a psychologist in the early 1900s, a woman in the early 1900s, which is itself remarkable. She had people in groups come into a room in which she was projecting the faint image of a banana on the wall. Now she had two groups come in. One group who were concentrating on bananas. She had them before they went in concentrate on bananas, and another group just come in and do whatever they're going to do, the control group. Now, those who were cognitively imagining bananas, it turns out the same circuits in the brain that process perceived images also process imagined images. And if the person is imagining bananas, they don't see the bananas on the wall. But if the person is not imagining bananas and just walk in cold, they see the bananas on the wall. So it's interesting that these perceptions can be displaced again by one's conceptions. We as instructors, we need to speak in complete sentences. I had a professor at Idaho State University in real analysis, graduate real analysis, who spoke in incomplete sentences. Almost every sentence the man spoke, uttered, left out a noun. And then he would complete his incomplete sentences by saying, you know. I felt like saying, no, I don't have the foggiest clue. You left out the subject of the sentence. I don't know what you're talking about. So complete sentences is important. A linear train of thought, something easy to follow. Rationality is also important. In terms of how we speak, we should speak clearly and enunciate well. It's an important part of the communication process, and we should also write neatly on the board. This is student work. This is a student paper, and the answer that this student gave to this problem is absolutely correct. What's difficult, and what jumped out to me here, and I wanted to give an answer that was actually done correctly, but it was written badly, is that this symbol here and this symbol here actually represent two different things. Okay, this is a T and that's a plus. Okay? This is a plus, that's a T, that's a minus. Okay? This is a T, that's a plus. You can see the, what is this? T. What else could it be in the context, right? Sure looks like a plus. And T and plus, T and plus. You can see that the distinction between T's and pluses is minuscule, just unrecognizable. And so this is a problem that students have with us. They come trained to write things in ways that are difficult to read. And sometimes we communicate in writing on the board in ways that are difficult for our students to read. And so I'd like to talk about a few handwriting tips. The script T as a substitute doesn't look like the plus if you make it a script. And the capital T can sometimes look like a lowercase t, and you can distinguish between those with the script T. The numeral 7 can often look like a 1 if written badly, but no matter how badly you write it, if you cross it, it still looks like a 7. So this is a way of clarifying our communication with our students, even if we don't do this when writing to ourselves. I think it's important to do this when writing to students. X can be confusing in many situations. It can be confused with Y, but we can make clear distinctions between the two by using script letters in both instances. Sometimes if I use this type of Y instead of this one, this would look like XXX instead of X cross Y, which would mean an entirely different thing in a mathematical context. S can sometimes be confused with 5 or vice versa. This 5 looks a whole lot like an S in this case. I've seen students go to the board and write a Z exactly like a 2. Okay. Well, what's the cure? Even if you write it badly, if you cross it, you won't mistake it with a 2. It will be a Z, no matter how badly you write it. And then decimal points. A decimal point like this could be mistaken for the relic of a prior erasure, relic of something that you wrote before, left over after the erasure. Student may be confused, is this a 2 or is it a 0.2? You can always clarify that by putting a 0. And in computer science, they cross zeros as opposed to O's, but in mathematics, this symbol is reserved for the empty set. So we still get those confusions between zeros and O's, but not so much. Memory errors. It's very important for trig students to memorize a very large number of specific facts at a level of automaticity. When they see cosine of 30 degrees, they need to immediately say root 3 over 2. It needs to come rolling right out of their brain without much thought. It should avoid those higher conscious levels even, if they are going to be successful at solving trig equations later on in the course. So if we don't compel our students to memorize a large number of facts early on, they will fail at properly forming concepts later on in that course. They'll crash and burn and fail the course. This rote memorization is a necessity for concept formation later on. Procedural errors. I remember reading about a student, elementary school student, learning the addition algorithm. You carry to the left, right? You carry to the left. He couldn't remember, did you carry to the left or the right? His teacher told him, you carry to the side that the piano is on in the room. Okay, so he carried to the side the piano was on in the room all the term. Next year, he's in a different room. Piano's on the other side. He's carrying the wrong way. Teacher asked him, what is he doing? Well, my teacher last year told me that you carry to the side that the piano was on. Okay, so he was just faithfully following the instructions that his instructor gave. You always go to the side of the piano. So, here's another classic procedural error based upon a student's relying upon intuition rather than formality. This intuitive culture that we have leads students to make procedural errors of this sort. They don't want to memorize the correct procedure. They just want to know how to intuit everything. They don't want to know what anything means either. State the definition of the derivative. How about this? The instantaneous point of a tangent line. Huh? Does this mean anything? I don't know what this means. This student clearly has issues with respect to meaning processing the meaning of the derivative. I don't know what the student is trying to convey here, but instantaneous point. I don't know which point on the tangent line is the instantaneous point. I don't know. And I thought it had something to do with slow. Anyway, communication errors. This is obviously a solecism, which we talked about earlier. Here's a classic example of a trig problem. Solve this equation. Now, to solve this problem, students have to understand the notational conventions involved. Square means you don't compose the function with itself, you raise it to a power. They have to place the problem, and they also have to know that when you take sine squared, it's not sine squared times x, it's sine squared of x. That there's a function evaluation going on. Some students just divided the sine squared off. That was awesome. But they have to place the problem into an appropriate algebraic context. They have to solve it by moving a term to the other side, dividing by the 4, taking the square root, and solving it that way algebraically, or they have to use the quadratic formula, or they have to try to factor. My students attempt all of these methods. I had 251 students attempt this problem. 251 students. The vast majority of them did not earn all of the credit. I have to point out. They have to correctly employ the algebraic procedure. I had a lot of failures in that context. Quadratic formula, crash and fail. Factor, crash and fail. They have to place the algebraic solution to the right trigonometric context, and then they have to employ the trigonometric solution procedure correctly at that point. So there are a lot of complex steps in the solution of such a simple problem as this one. So 60 out of 251 students solved this problem with no form of error at all. Did I crash and burn? Maybe. This may be a very sad commentary, but this is reality. This is what actually happened. 60 out of 251 students had no form of error whatsoever, just giving the right answer. So only a few students did not understand the notational conventions, just a few. 75 students made the error of leaving the negative sign off when they took the square root, and so they only were able to arrive at half of the solutions. That is an error that is algebraic in nature. It's not a trigonometric error. It's a failure to comprehend the square roots. It's training that occurred prior to my class. 75 of them made that error in my class. But I wasn't training them about square roots. I was training them how to solve trig equations. So there's a lot of prior knowledge being fed in that these students haven't quite grasped because they refuse to learn things formally instead of the informal, intuitive, which they prefer, which they're deeply acculturated to. 37 students left the problem completely blank. 37 out of 251 drew total blanks on this problem. There were factoring errors, quadratic formula errors, memories of the values of sine. A lot of students could not remember the correct values of the sine function. They couldn't figure out the reference angle. They had trouble. Some of them applied identities to this problem, believe it or not, and they incorrectly applied various identities, so they had trouble remembering those identities and then misapplied them here. So what is the resolution of this? I believe that from my observations, the vast majority of these errors were due to weak algebraic skills, both procedural and these skills were prerequisite to properly solving the problem. And so square roots, of course, the biggest problem. There were a lot of memory errors. Remember what we're trying to do. Memory, procedure, and meaning, in addition to our students' ability to deduce. Another error example, this is symptomatic of a student to learn a process but fail to understand or retain that the process applies to products without sums. And the student quite likely doesn't know the difference between terms and factors, so they don't know how to properly form the concept of how square roots work. They can't form the correct concept because they don't know the meanings of the words that go into the theorems. So this formal meaning is essential in mathematics. So what is the cure? Well, we could just change the whole culture. A fat chance. Okay. We can emphasize formal understandings of the meanings of words throughout. They need to learn the language. Proper conceptual understanding of the process, awareness of false generalizations, training to recognize differences. I guess it's getting late. What I'd like to do is just complete this lecture by going to my very last slide. Let's see if I can, second to the last slide. I'll go on that. I was going to talk about logical errors and whatnot. Oh, also about mathematical conventions, which is another big topic. But at least I can conclude by talking about my monument to error that I keep in my office. A monument to error. Yes, this is my monument to error. I made these polyhedra out of blocks of wood. This one is a piece of oak that came out of my tree during Hurricane Rita. And these came from a piece of sweet gum that fell out of my neighbor's tree. And so I made these polyhedra and I keep them in this basket. Now, why is this a monument to error? Well, do you see this thing, this little pedestal down here that this is resting upon? That was my first attempt at making one of these, a dodecahedron. And what I did is I calculated that if I wanted these sides to be 1 inch in length, then it needed to be 2 1/4 inches between the parallel faces. So I made a cube, 2 1/4, 2 1/4, 2 1/4. I had my little pentagon run on the top. I thought I knew where to place it. I started cutting and I realized that's never going to be as long as this. It's not going to be 1 inch over here. Which means the error that I made is that it needs to be wider and longer than it is thick. I didn't take into account enough information in order to produce this object. Now, this represents the concept that our successes are founded upon our mistakes. I think that's true for all of us. So I'll quit there. I'd like for you to tell me about your errors, and your students' errors, not your errors. So I'm sure you don't make any. Let's see, I didn't bring a sheet of paper and I'll steal these notepads and see if you have some insightful errors to bring to me. Yes?
Yeah, one that drives me crazy, and I think it's lapse, but you can tell me what it is. I give a couple of open book tests,
Yes.
and it's a minerals identification, rock identification, and it's open book. So during my open book tests, I insist that they spell the words correctly since they can copy them out of the book.
Right.
What a horror, I'm a real dummy, I'm assuming that they can do that, you know, and what you'd be, I don't.
It should be a direct
why-
transcription.
Why can't they just write, I mean, it's, you know, it bothers me a lot, it really does. Particularly since I emphasize to them 2 weeks leading up to the test, it's spelling counts, and here's like, you know, copy the letters out of the book. And it doesn't work, I never get improvement there.
Yes, all of your admonitions go bouncing right off the skulls. Yes.
I've got a contrast with your derivative problem. In chemistry, there's sort of two sides. There's learning the concepts, and then there's learning procedures, like calculating a percent yield or something. And they often, students, you do have to teach both, because in my case, you can learn an algorithm for calculating a percent yield, even if you don't really understand what a bowl is or what a limiting reagent is and all that. So you have to separately teach them from the concept of the algorithm, because if you don't teach both of them, they could sometimes do one and not the other.
They can proceduralize without formally understanding meaning,
Yeah.
and they can form meaning without being able to form the procedure.
Yep.
It's
I
completely a
see.
separate area of the brain. Yeah, that's great. So you say a mole percent kind of calculation? Is that
Yeah.
right? Mhm.
One that I had recently was kind of like Mike, and you know, it's a science, so there's a lot of math in it, but it's a science, so they can see a problem, have seen it on the homework enough times, or not the same problem, but something similar, to understand how to do the problem without knowing why they're doing what they're doing.
Yeah, the ability to process the procedure without knowing anything about the meaning.
Right.
Yeah.
And that happens a lot. Like I'll ask them to solve a conservation of momentum problem, and then I'll ask them to tell me why is momentum conserved in this problem. And they can solve it really well, but not tell me why momentum is conserved. And some vice versa. Some can tell me why it's conserved and then do not have a procedure in place to actually carry through the solution. So it works both ways, but I definitely try to ask both because I think both are important.
Yes.
I've got a question.
Yes.
Setting aside learning disabilities. Is there a direct relationship between the motivation to learn and the number of errors that a student makes?
Well, that's something I can't really comment on because I didn't collect any data about student motivation,
Do you
other
think-
than I just wrote the F on the top of their exam.
Do you think that there is?
Do I suppose, can I hypothesize that there's a connection between motivation and number of errors? I know that that's true. In fact, I know that some students who are not well motivated sometimes drop a class, just because they don't find themselves motivated enough to actually put themselves to work and learn the material. So we see that even, students maybe even dropping out of a major, perhaps not being motivated enough to stick it out and do what was necessary. Yes.
Slightly off topic, but my son's in elementary school, and when he was in second grade, they introduced multiplication to the kids without making them memorize the times tables. Is that something that you would? It drove me crazy because I'm from the old school,
Yes.
where every morning we went to our math class and we said our times tables out loud.
I was going to mention two schools of thought, neo-progressivism and essentialism, or constructivism and essentialism. And in the neo-progressive or constructivist schools of thought, you're supposed to let students kind of figure out their own methods and their own procedures without emphasizing memorization. What you find in mathematics, in my experience, is that students then find themselves unprepared to formulate new concepts. And so they crash and burn. Yeah, I talked about the addition algorithm, the carrying. In some schools, they don't even teach the addition algorithm. They expect students to figure out all on their own how to carry or not carry, or adding left to right or right to left, or whatever they do. They can figure out their own methods. And as long as it works, it's okay. So then memorize? Why should we memorize anything? No, if you do that, what you're doing is you're leaving a whole region of the brain undeveloped.
Okay. So I was right insisting that he memorizes.
Absolutely.
Okay.
Absolutely. Memorization is a key element of what our human capacities are. And to fail to exercise that is to fail to exercise part of what makes us human.
There's a direct parallel with the way literature was always taught until the last 20, 30 years. You were always asked to memorize poetry
Yeah.
and then recite it
Yeah.
in front of the class.
But now who cares? Yes.
I used to give and I got so frustrated I stopped doing it, but at the beginning of every semester, I would just give a crazy quiz that didn't count for anything, just a general knowledge quiz. I just wanted to know what students knew. And one of the questions I asked on the test was add 1/4 plus 1/3. And a third of the students answered 2/7.
Oh,
Consistently.
Yeah.
Consistently, a third of the students. So,
Pass.
and that worries me because my wife is a 3rd grade, 4th grade elementary teacher, and she's shocked that college level students can't add fractions. So I guess that's, from what you've described, that's not surprising, right?
I have to say, we have a lot of success over there too. I wrote a letter of recommendation on Monday for student transferring to A&M. We get students transferring into engineering programs and science programs and technology and computer science, whatever, from our program. And I think that when it comes to doing something of real value to our students, that's a lot more valuable than these SLOs.
I think one of the problems with your issue is, your wife teaches that stuff, right? So the question is, why can't they do it? And I find that the students that I have that struggle with math, applying it to physics, is mostly or often because they haven't done math in 4 years. Because when do they have to do math between 9th or 10th grade and your class? And for some of them, it's been 2 years, for some of them, it's been 10 years, for some of them, it's been 20 years. I mean, if you don't do 1/4 plus 1/3 for 10 years, you're not gonna remember how to do it. I don't care how well you were taught.
So they've lost the formal knowledge, but they're still working on intuition.
But
Right.
at the same time, I come from another school, okay? And I found that here, they teach by memory math. You have to, the FOIL. You FOIL. What is FOIL? The first time that they told me FOIL, For me, foil is that thing that you put around a potato. That is foil. Foil is not foil. This is distributive property. Why you don't call it the name that it should be called? Why they call foil? Oh, you foil. But how I do this square? Foil it. Foil it, and then when you arrive to trigonometry, Sokotosh, what is the thing that they say?
The students sometimes ask me what to memorize. Sometimes they'll even prefer, they'll say, okay, well, what do I memorize? What formula do I use?
Yes.
And because if they have to, and sometimes they learn in high school, they have to, oh yeah, you just memorize this, and then you get that, and then you memorize this. But to take a step back and understand the concepts often takes more brain power, you know.
Well, they
than
will
just-
memorize, that's the function of the sacred study guide just before the test.
Yeah,
They're
yeah.
used to this through high school, and if it's not provided to them, it's like, you're not feeding me, you know? And that's when the memorizing starts, big time, you know?
I think that we do teach a lot of concepts. We develop, we prove the values of the trig functions, but we want more than that. We want more than their understanding the meaning about why the trig functions have these various values. We want them to automatize those memories.
But Jeff, we want to help the students, right? So are you suggesting that it's useful for the students to better understand what these types of errors are? That is to build in self-consciousness, which is the Enlightenment 18th century way to liberation. If they don't know what they're doing, they're condemned to keep doing it over and over again. Or is that just naive with respect to handling?
I don't think it's naive to expect that our students should know that sometimes a formal understanding of the definition is a prerequisite to a functional understanding. We want both. We want it all. And I don't think it's wrong to tell them, you need to be aware of certain errors of false generalization. These are the things that we observe, don't do that. Okay,
Well,
and you
have you
don't
found
do it
that
because
helps?
these are the principles involved.
Does that work in your classes, making them aware of the errors? I mean,
60 out of
conceptually
251
aware.
answered that one question correctly, so maybe it's still not penetrating. Anyways.
I have a couple of questions. Intuition, is that the idea that the reality springs from within, you know? In other words, I'm coming up with my own definition, is that the idea?
I think intuition is when you treat things informally and expect to process meaning without any formality.
Right, so it's extra nuts, in other words, the principles come and I'm learning them, I'm not formulating them.
We want an intuitive understanding ultimately, but we want to base that intuitive understanding on that formal understanding.
Right, and if I'm a tutor and I'm working with a student and I want the aha moment, I grew up, we ground the math. I mean, it was just a long, hard slog. And it was a lot of work, right?
It's good for the soul.
Yeah, well, yeah, but, you know, you were sitting with a student and you want them to get it.
Yes.
What can you offer? I mean, what is the, you know, besides helping them, giving propositions about the meaning and showing them the procedure, I just learned that it was always a constant application.
But I think that you have to point out to your students, here we're using the distributive law of multiplication.
And
Here
you
we're
want to
using
point
the
that
commutative law
out?
of addition.
Point
Yeah, I
that
point those
in
out.
a spot where they can objectively see it and then apply it and always, but is it something
You
that?
have to refer back to those elements sometimes.
I was just gonna say, to me, it's like Karate Kid, like we have to teach them critical thinking and this memorization. I don't think we can hit up Bloom's taxonomy in 15 arbitrary weeks. So, you know, my class is a vocabulary class, right? It's theories that aren't scientific so that they get an understanding of what this endeavor to understand humanity is. And you need to know these terms so that you can speak intelligently about when we get to the next section. And I don't get to teach them the next section because we don't teach the next section here.
And when it comes to Bloom's taxonomy, which is the lower order thinking skill, processing meaning, forming memories? Meanings is lower on the
Meanings,
triangle,
it's
right?
meanings.
But
And-
which of those aren't they handled just by different regions of the brain? So which of them is higher order, which of them is lower order? Which one are you willing to do without? I don't think you can do without any. I don't think there is an ordering on these functions of brain. So when it comes to Bloom's taxonomy, I have to object that I don't think processing meaning is higher than processing memory. I think they're parallel. I think we need both.
I think Bloom's taxonomy is pulled out of the holster all too often, all throughout education these days.
Right.
It's become the holy grail. It's Bloom's taxonomy. Oh my God, what does Bloom say about it? I think he'd be rolling over in his grave if he knew all the places that taxonomy is applied. Not that there isn't value to it, but the way it's just pulled out and stuffed into every sausage case imaginable.
So I wanted to shoot this out real quick, because there's English professors and tutors and one here. I thought this was gonna, I know you're a math professor, but taken for granted, I just wanna throw taken for granted out there and ever since. Because those are the two biggest errors that my students make, and those are the ones like nails on a chalkboard. I take it for granted, I'm like, nope, it's plexi, okay? And ever since, and I'm like, every sense, right? So to me, it's the grammatical errors that crack me up, that show that they are just memorizing what they're hearing and then following that over and over. It's not even a grammar check issue, they think that's the right word, right?
It's a
And so-
solecism.
Yeah, and I get the, they're, all the time, but take it for granted. That was just, I love it and I hate it. It just, yeah.
Well, you want
Well, you would, of course you would. You would have all that. That would upset you, right? Somebody shows something called Canada. Yeah. They show
I take it for granted.
When I was in school, I remember, I could do the math and follow the symbols, but I had a real hard time in English with the comma rules, so to speak, comma
And apostrophes.
conventions, and when to use a semicolon and when not. I found grammar to be very, very difficult. Now we're saying, well, you learn the fractions, okay, early on, and then you don't use them as much, and so that tends to get lost. All right. I worked real hard with this grammar, but then the only place I began to really use it was when I was writing my own papers. Okay. So I wonder if you could comment on that the idea of how does one learn punctuation and the
Well, I think that's one of the hardest things for non-native speakers in English to master, because in English we do not write the way we speak, whereas in other languages they write more the way they speak. The comma rules in English are not necessarily logical. And also, I don't know that you were having a problem with grammar. The comma rules would be more the semantic component of the language, I would think, rather than syntax. But that's just splitting hairs, but you gotta memorize that stuff, but if you do it little by little, and, that's true of everything, right?
So
They probably have the same, they're very similar problems, I would imagine, has to do with learning the rules of grammar and learning the rules of math have to do with rote memorization largely. And students are opposed to anything that have to do with rote memorization because they've been indoctrinated that there are no truths, which they interpret as there are no facts, which then goes to everything's an opinion, and all that they care to know is and every opinion is valued the same, particularly with the internet. Anybody can have one, write one, start a blog. And so now there is no knowledge to pass down, whether it's math or grammar, because it's all just a matter of opinion.
That is in part because of the resistance that students have and people generally have to forming formal understandings of meaning rather than intuitive understandings of meanings. And I think you walked in after my example of the question, where is a table? What is a table? What is an item of furniture called a table? And
So is the district really shooting itself in the foot with this big drive for completion? Must complete, must complete. Well, okay, I gotta complete. Well, if you want me to memorize and think about things at a deep level, how the hell am I gonna complete? I gotta complete.
Well, Bill, that's not pedagogical, it's political, and that goes into another.
Yeah.
That's another CAC.
I think we can focus on the first slide after the second slide.
That's another
That is-
10 cats.
The big issue with completion occurs outside of the classroom. The big impediments to completion occur outside of the classroom, in my view. And if they're focusing on what we're doing in the classroom, they're kind of barking up their own tree.
So to summarize, you come out with there's three centers, there's memory, there's procedures, and meaning.
And meaning, but there's also the logical deductive centers of the brain, and there are communication centers as well. You can write whole books on all of this.
So as we're tutoring, we want to make sure that all three of those are sort of like
Yes, and
operating
we're
at the
deductive
same
as well.
time, operating at the same time, and always trying to energize on all those levels, maybe.
We want all of it. We want them to have a formal understanding of meaning. We want them to have that formal understanding automatized so it comes immediately to mind what the actual meaning is.
Right.
When it
Using
comes into
analogies,
use.
using analogies.
They need to know the procedures. They need to automatize the procedures. They need to form specific memories and large numbers of them, and they need to automatize those memories to the point where these thoughts, these memories, these facts leap into the brain without much conscious effort. So we need all of that, and we would like to train our students to think deductively. They need to know how to find the contrapositive of the statement and use and prove the contrapositive, thereby proving the original theorem. I was training my differential equation students to do that today. We need to train them. I'm just going to show you some other logical errors that we commonly see, even in calculus 2.
Well, someone could take what you've said today and spin it in a way I'm sure you would be comfortable with, nor would most of us, I think. Well, what we need to do is go back to the way teaching occurred in the 19th century.
Yes, I'll get out my
You're not
ruler and
having-
whack you on the fingers
well,
if you make a
no,
mistake.
I don't mean that, but I mean the emphasis on memorizing certain things and not being embarrassed about the fact that you're requiring memorizing. And you're not advocating anything anachronistic like that. So what can we do, assuming the culture is not going to change, right?
Right.
And that we're working in public education, and that's probably not going to change much. And so.
I have control over my class. When it comes to my class, I like to, first of all, lay the foundation of formal meaning. And as we've seen, in the state the definition of the derivative and then use the definition to calculate the derivative, that understanding of that formal meaning is a prerequisite to the functional meaning. And so, in this sense, that may make math different from other subjects, but sometimes the ability to have that formal meaning well placed in mind is a prerequisite for developing that functional understanding. However, it's a necessary but not sufficient condition for what we really want. We want the whole enchilada. We want a formal understanding and we want a functional understanding.
Yeah.
So
There's a lot of calculus. When I went to calculus, I did the derivatives and intervals, but I never did the why or what this could, what is the meaning? And it's tremendous, these things, the applications and all what they're doing. But it's kind of both ends. I want to do the hard road work back. I would have loved to have learned the why, the flavor, what math theory, all
Part of it's just time too. To get all of that, you need more than one semester. of
Yes.
that subject. So,
that may be the case, though I do think that in our trig class, we derive these values that we want them to memorize. They have a rational basis for believing these things. And we're not just telling them to memorize it, rote, take it on faith, that's it. No, we're showing them why, and then we're saying, we want more.
right. I mean, I'm not saying that you can't develop all of those ideas in a semester. I'm saying that they can't learn all of them very well in a semester.
Yeah, that brings up the once too late principle in math. You learn it, but usually in the next course.
That's right.
Yeah.
Too much memorization is not exploding your mind.
Well, we want our students to remember all of the trig identities, for instance.
No, I mean, they believe they are thinking it's going to hurt them if they memorize.
Yeah.
We shall prove otherwise.
Jeff, I'm sorry to interrupt you. Let me take a few seconds to announce next week's meeting, and then we can continue. Next week, Kevin Nguyen, Frank Granick, and Jim Zipper from the business department, they're going to talk about current topics on Federal Reserve, I read it correctly. What an average citizen needs to look at.
Bring your pitchforks.
So, Jeff, what do you think we should do with all? What do you think we should do? You said you're going to stick to your gun, but I go in class. I mean, I have John. You said that you have a little quiz there. I do every semester. The first day I call the first day quiz, and when I go to my class and look at it, I sit down and cry over it.
Because in calculus 1 class, you expect a student know that x plus y quantity square is not x squared plus y squared, as you mentioned, and all of them write that. I mean, I go to my office and say, okay, should I go back and teach them college algebra again, or teach calculus 1 as I'm supposed to?
Yeah, so what do you do when your students come in largely with deficits from prerequisite courses?
Yeah.
It's called the School of Hard Knocks.
Yeah. You have to teach your course.
Yes.
I also want to make a comment on John's comment. You said the students, even though they have a book, but they write it incorrectly.
Yes.
Sometimes among these, because I have 2 little kids that are going to a school right now, and it seems these days it's bad to be good. For example, if you memorize everything and you're doing good, making 100 in class, you will be hated by everybody in grade schools. They call you names, and so either they have to keep a low profile, don't say anything, or just on purpose flunk the course because they want to be one of the others.
Time to change schools.
And that relates to completion how?
Exactly.
If you want to keep going, once I asked one of the counselors here,
Student engagement.
what is the profile of the students that we are going to have in the next 5 years? And she said, you know, I sit down with the other counselors, and what you are going to receive is students that they think they know, and they don't have to prove you what they know. That was the answer of the counselors here. They sit down, several of them, and that was the profile that they gave us.
I think I mentioned this guy last week's CAC or the one prior. So Daniel Kahneman and Amos Tversky, they sort of traverse various fields. They're mathematicians, they're economists, they're psychologists. One's passed away. But they're Nobel laureates, or one of them continues to be. But they talk about cognitive illusions, cognitive biases, cognitive errors, his most recent book, Thinking Fast and Slow. And I show my students a clip from them from 25 years ago, and they're cocky, and they're arrogant, and they're saying some of the things we're saying in here, like, oh, kids today with their rock and roll music, you know, all these things like, oh, you're wrong, and this is where you're wrong. But 25 years later, they're humbled, or one of them is, because he said, you know, I know what all these things are. I've been studying it for decades. I still make these mistakes. I'm still going to grab the wrong key, because that's the way either brains are wired or my brain is wired, okay? So I think it's interesting that these brilliant individuals can say there are limits, even when one studies what one's limits are, one can still be bound by them. And then I also want to throw out, a student taught me this, it's got your keys out. Albert Einstein stated, and I think you read the most recent biography by him, that I never memorize anything I can find in books. And I thought that was a really weird quote to come from Einstein. And I found it, and he said it. So here we are saying memorize, memorize, memorize. Now certainly his brain was different, but he basically said, why should I memorize? So when our students come here 5 years from now and say, why should I memorize anything? Instead of deriding them, certainly they're not Einstein, right? But they can Google it, they can wiki it.
The point is, there are certain things that need to be memorized.
Yeah.
And there are other things that if you memorize, you just clutter in your mind.
Mhm.
Yes.
And so what we're talking about here are the things that must be memorized in order to do the procedures that we need to be done.
Right.
I'll give you an example of why some things need to be memorized. Like, if I have a molecule that I'm trying to synthesize from stuff I can buy at the chemistry store, it'll take me many steps to get there, but to plan a synthesis, I have to, in my mind, already have a whole bunch of reactions that I know that I can use to get there. If I don't know the reactions already, I can't plan a synthesis. Now, I might be able to look up, oh, I forgot the solvent or the temperature or something, but if I don't know that you could take a carbon-carbon double bond and hydrogenate it to a single bond, it won't even occur to me to do that in the synthesis. And I think that's true of a lot of subjects where you simply, there's some things you have to know to just solve a problem. You gotta know what momentum is to solve a concentration.
That's a fascinating, because if you had one misinformation, misformulist piece in there, it would mess the whole thing up. So if you're learning real facts and you're able to weave those things together and form a procedure, if one of those was missing, like you had a misconception, it would blow the whole thing.
I think it's also instructive, and I encourage us all to do this. Ask your students, it takes 2 minutes, what does the word free mean? What does free mean? And just ask them to write it down. You know, and how many, there'll be some, to be free, it means nothing left to lose, you know. Free means no restraint, that's what you get. No restraint. And that is a product of the 60s and the early 70s par excellence, and we're still, within that paradigm. That is not what free necessarily means, and that's, if you believe that free just means no restraint, I don't want to memorize anything, I'm not creative if I have to memorize something, right?
We're talking here about the students' mistakes. Now, how much of those mistakes are not founded in the way that they have been taught in schools and the mistakes of the teachers that they have been having on the school? How much is that we have told them, memorize this, that is useless, they should have been understanding that instead of memorize, do these things as I do.
But I think I answered this question with respect to the solution of trig equations. If our students do not have, at some level of automaticity, the memory of certain facts, then they will fail in solving trig equations. They will not be able to formally develop that ability if they don't have a fair number, and I'm talking about dozens of specific facts in memory at some level of automaticity. They should also then be able to go back and reverse engineer to create those facts from the meanings that we have explained earlier in the course, but they need to have that at their fingertips just to be able to formulate this new process. They won't be able to formulate that process without the memorization.
Well,
I think,
please go.
I was going to say, I think just responding to the Einstein quote, I mean, you don't have to memorize anything if you're willing to do it on your own. In other words, if he was willing to do it on his own. So he memorized plenty of stuff, I guarantee you. He just didn't think about memorizing it because he had enough motivation that his teacher didn't have to tell him memorize this, because he worked at it enough that it just, if you do it enough, it's gonna be in there. Like I haven't memorized trig cosine of 60 degrees. I haven't thought about memorizing that since I was in 9th grade, but yet I haven't had to, but I've done it enough that it just sticks in there now. I have a feeling that's what Einstein meant, was that he didn't go memorize something that wasn't useful to him because he hadn't used it enough times to have to memorize it, and otherwise he'd just go look in a book or he'd find a mathematician to help him.
This reminds me of the Nobel Prize-winning physicist, he's a Schwinger. He would go to lecture and speak extemporaneously. He never carried notes in the lecture, but one day he needed to know the cross-section of a particular cross-section of some nucleus. And so he reached into his pocket and pulled out a note and wrote that number on the board, put that into his pocket, and his students roundly criticized him because he had required it. Yeah.
Well, one thing about when I tutor is that I always thought math was like you're presented with something and you map out an array of tools you're going to apply along the way, and you have to know what the tool is and when to apply it and what the combination is going to lead to. And when I work with a student, I would want to, when they go, oh, I like to want to reinforce that, because reinforcement will logic, what I'm saying, when they have a misconception and they turn it around and get it right, I want to be able to encourage and provide, that's good pedagogy, apply that tool right instead of something they've been doing wrong.
So you're
it's like there. Well, you talk about the learning the procedures and helping the students.
Yes. And
you want them to get the right meaning, but also the right procedure. And so when they do, when I work with a student one-on-one, I want them to
see them using
get it
incorrect
and also
procedures.
feel good about it.
Okay, but you see them using these incorrect procedures, and the reason they're doing these things is often because they're resistant to forming formal meanings.
Right.
They're much more comfortable forming intuitive meanings, because that's true across all cultures.
So hopefully we can encourage them to be encouraged and excited about the formal meetings.
Because they cannot remember the conditions of various theorems if they don't know what the words mean going into those theorems. They can't properly form the meaning of that theorem without knowing what the words going into it mean. So if the theorem only applies for canceling common factors, and they don't know what a factor is, they're going to interpret it as you can cancel stuff in fractions, which leads to errors of false generalization.
I think there's some cause for hope in that. I don't think that we can talk about the entire culture, paint such broad strokes about the entire culture. And for example, take baseball. All right, there are sports. There are automatic procedures that need to be performed in order to be a good baseball player, right? And that we enjoy learning these procedures if we enjoy, learning the game. It was interesting that the baseball coach here told me that one year he had about 18 students turn out for the team, and he could barely field 9 because of grade average.
Oh, I see.
But they were fine baseball players. In other words, the things that we're talking about here, presumably painting very broad strokes, youth nowadays aren't presumably able to do. They are able to do it. They're just not doing it in certain contexts. So the task is to, get them to do it in the math class short, and I really want to emphasize this, short of teaching a course called, math and baseball, or, learning math through baseball. That's just pandering. But there's got to be another way, to do it. And just that, baseball's just a very good example,
Well, you mentioned reinforcement, so that's my area. We all do it because we all teach, but that term wasn't really in the vernacular until the 1940s, and the way we teach, et cetera. So, they're doing this stuff. It's just called, I played it for the first 10 minutes last time, Candy Crush, right? So they're doing this stuff, they're learning stuff, but it's on their terms. And so the breadcrumbs necessary, maybe we're not reinforcing those small successes because we say you should be here, right? You learned this in 3rd grade. Sure they did, but they haven't used it in 10, 15 years. So maybe a remedial, instead of the 2-minute quiz of what do you know and what do you don't know, it's can you take this via, let's say, Angel or D2L, like we have to do, and do this 1-hour component to bring you back to speed from all the junk you don't know from before. And I don't know if you guys if you do that or if you don't do that. Because
maybe there's a misconception in there, and what you want to do is use
Totally.
questioning to find the neural pathway to get the misconception,
Right.
and then apply a formal ministry to it, and then I get it, the whole thing, the whole scaffold comes in the schema is prepared. What you have, I don't know. I mean, that works one-on-one when you're able to trace it down. I didn't know you had to, the 13 over 18. You know what I'm saying? There was a misconception somewhere, right?
Yes.
And to trace it, but that's it's not too.
That might work for just a specific example, but in general, might not.
But you have a whole classroom of people, and all kinds of whatever.
So if I taught math, which I never will, but I discussed this in class today. I say, raise your hand if you've ever heard that the definition of insanity is doing the same thing over and over and expecting a different result. And they raise their hands. Where did you hear that? I don't know. Who thinks it's true? Most of them, okay? And they say, who said it? Einstein. It's always Einstein. Einstein said it. And I say, Einstein never said that. The definition of stupidity, and you guys might want to use this in your, is doing the same thing over and over and expecting a different result. In other words, how's that working out for you? Okay? Well, it's not. You're failing math, or you're failing English, or you're failing whatever, because you're applying the same intuition or lack of procedures, and it's just not working.
That's why I want to be encouraging and always not try to. In this culture, nobody wants to look low, like I'm mistaken. So I would want to, engage and try to find that place where there's an errant place in the scheme.
Yeah, we shouldn't overlook the cultural context here. I mean, your presentation is it's symptomatic of the ills of American education. I wonder how relevant it would be in Japan, Korea, or Finland.
I guess that some things are the same. I always question myself that we have been lying to the new generations. We have been saying big lies to our young generations. The first one is, oh, learning is fun. Yes, reach the Himalaya, reach the highest peak, the Everest, it's fun, but you have to work very hard for it. That part was missing. About learning is fun. That is one of the first ones that we have said to our students now for some generations, like 10 years or so.
And coaches, when you do something wrong, the coach would rap you on the head, the teacher would, they'd go all over you if you had an error. Because they were like thinking, if he buys this, it's gonna jeopardize his future. So I don't know whether that was negative reinforcement or positive, whatever, but that's just.
I just want to, because I knew that would come up, so let me just say, negative reinforcement is the most misused term within all of psychology, so that's one I got to beat, and that's Friday. I have to beat that out, and that's one of the only things I beat out of my students. Even Sheldon on The Big Bang Theory gets it wrong, and I say, he's your smartest guy you know, the TV personality, and negative reinforcement is always confused with positive punishment. And there's only 4 choices on the test, and they screw that up. I'll tell you what, I'll keep track of that on Friday. And I would imagine that 70% of them will get it. I say it's the easiest, hardest thing I teach in this class. You have 4 choices, and they get it wrong.
Every time.
Because it's the culture. Because we've been lazy about it, and you learn from a smart person that that's what you say, and they weren't right.
Right.
And so we just keep
And
on saying.
a coach in football, if you don't know what you need to do in that play, you ruin the team. The play won't work. And so if you miss a definition, or you're missing the conception, you're howling your future.
Throw one other thing out. The reason I asked that question about motivation is a little more deep-seated and underlying, see what the rest of you think. I think one of the problems why students that they're not motivated to learn, and the reason is that they're not in school. Most of them are not here to learn. They're here to check off the boxes so they can get a job, or check off the boxes and say, yeah, I graduated. But they're really not here to learn. I'm blowing my own horn. I went to school to learn. Okay, the last thing on my mind was getting a job, for goodness sakes. It was fun. Learning was fun. I mean, there were a couple of courses that drove me nuts, but for the most part, I'd give anything to be back there again. Take all the courses in the
It was the
catalog.
fun of going to the Everest. It was a fun that has a lot of work in the middle.
So if students are here just to check off, I took my 2 sciences, I took my 4 maths, and I did it, and I got the degree, they're not gonna be motivated not to make mistakes.
And maybe that more and more of an approach of a meaning, and the drawing of memories, going through the motions. Who's gonna learn going through the motions?
Forming all of these is
Last
difficult.
minute.
Forming all of these, you're overcoming inertia. Meaning, memory, and procedures. Those are all difficult. And so is learning deductive logic or inductive processes. These are all difficult.
There's a faith involved in that too. Maybe we just lack faith, right? I mean, they're putting faith in us that at the end of this 15 weeks, that what they're doing is going to make sense and it's going to be worthy of their effort. And they don't have as much faith religiously. They don't have as much faith in the country. They don't have faith in society. Maybe a product of the 60s as well. And so you're really asking them, again, in my field, it's the marshmallow test, which you're probably aware of too, which is, here's a marshmallow. Do you want 1 marshmallow now or 2 marshmallows in 5 minutes? And 5-year-olds screw that up to no end, and our students do too, right? Why should, and our economy does, right? Why should I not just eat the marshmallow now? Because tomorrow may never come. Well, to hike Everest, you need to eat no marshmallows, right? For years, okay? And get up at 5 o'clock and do the hard things. And I don't think they really wanted, and we don't know all of our students, right? Plenty of them get up at 4 in the morning and miss that. I'm on the scholarship committee, I know that they do, I read their stories. But To do the hard stuff, I think they need the carrot or the marshmallow or something at the other side. And we're probably not it, John, right? I mean, we're the geeks who love this stuff. Some of your students that you love are like, they want to grow up and be like you. But if they're like, I hate your class, you're not going to be like, well, let me sit down with you, and work really hard on this. So
That's why it's so important to have models, people that actually model this, and
Ask
teacher
your
can't be a king.
students how much they want really, how many of them really want to study right now. I don't have to study. I can be like Bill Gates. Why not? Okay, we are in math. Do your ratios. How many Bill Gates over how many persons over? Let me know the chances that you have to be a next Bill Gates.
Here's another thing for my discipline, and Jeff, you read all this stuff, so you know. It's effort. You need to push that it's effort, not ability. Because if they think it's ability, they either think they've got it or they don't, and they're more likely to cheat or they're more likely to give up. But if you, again, the 10,000 hour rule is certainly questionable, but if you tell them if you work really hard, you'll meet a success that's not found in a common hour, right?
That was the biggest lie that I bought.
10,000 hour rule?
No, the idea that you're smart, you don't have to work.
There are, yes.
You can do whatever you want.
I worked so
That is
hard
the
that everybody
second
thought,
lie
oh, we're
that
so
we-
intelligent, we can pass the
Yes,
SAT,
that's
we can
insane.
get SAT and not have to do anything. And I thought, well, you gotta fit in, it's horrible.
Well, I think part of the problem is that it is in fact not effort, it's competence. And they are rewarded over and over and over again for effort. And then they get to your class.
Yep.
And they don't know what they're supposed to know because they've been rewarded for effort. Okay? It's orthodoxy in the teaching of writing, it has been for a number of years, to ask students to write a little paragraph of self-assessment before they turn in a paper. Okay? Maybe it would be much more useful, like what you're suggesting here in your presentation, to ask them to write something after they get the paper back and say, now what errors did you make? And how are you going to address them? Because if you don't do that, the next paper that comes in will be riddled with the same errors.
So you're saying the dichotomy between effort and intelligence is, you have to be oriented toward
It's not a
meaning.
dichotomy, I'm not suggesting it's a dichotomy.
It's not the opposite, but it's somewhere, it's having competence.
They expect a grade for effort, right? They expect an E
And
for
they
effort.
get it, and they get it.
Yeah.
Is in my country you say you have at least an E for signing the paper, okay? And that was the first lesson that I received when I was going to start being a teacher. The dean of the department said, 0 is a number. And the signature is not part of the exam. That is first degree.
So I mean, master the procedures and go through the motions and get my grade. But when it comes to meaning and being able to draw connections that actually build the confidence and the grasp, then you have to have all three. Is that the idea?
You just ask them, would you like to go to a surgeon who got A's for effort? I don't think so. You want to go to a lawyer who got A's all through law school for effort? Or do you want someone who's going to win the case?
Here's a question you should ask yourself about your teaching modality. If you believe that yours is better than, to the exception of all the others, place your teaching method in a context where your life depends on it. Are you willing to learn by exploration and conjecture how to storm a hill in a military context? Or how to swim a tide by exploration and conjecture?
Well, I was talking to some of my students who've gone through the military today, because we were discussing Pavlovian conditioning, and we'll get into operate on Friday. The military uses positive punishment. They use all 4 quadrants because they're smart. But they rip you and tear you down, and it's don't think, do this right. It's not conjecture, it's not how you feel, let's just get up and do it. Until you're an officer, right? I mean, true leaders, then they take all that, and then they have to throw it away because they need to assimilate information versus a comedy. Does that make sense? And so I think what we're saying over and over is, in order to play jazz, you should learn how to play the piano and then improvise. They just want to get on it right. or I want to make chess, you know, I'd love to just be able to play chess, but I've hit a peak because I don't want to sit down and learn chess. Does that make sense? I know I can become a much better player if I study chess, but I'd rather just play chess and get a little bit better over the next 5 or 6 years.
And your life doesn't depend upon that.
And it does not,
Sure you
it-
will.
thankfully, no.
All right, thank you, Jeff.
That's about
You know, Mike gave me everything my keys because that's how I try to open my office every morning.
it. Because you're parking?
Yeah.
Well, here's, the automaticity is,